Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 5-6, Systems of Equations by Deconstructing Word Problems. Today is Monday, March 8th. This is a Zoom lesson, but if you don't attend the Zoom, make sure you watch this video to see how to approach these problems. So today's learning target is I can solve the systems of equations word problem by deconstructing the question. So what you're going to see today is there are two word problems. One about Miss Manaya and Miss Townsend, and then one about Miss Kimmick, who worked at our school last year. So what we're going to be doing today is we're going to be showing you a method on Zoom of how Miss Townsend and I approach these problems to guarantee that you know exactly what to do. So question number one, and how these questions work is that they typically give you some background information right here, and then there's multiple parts that you have to answer. So we have some background knowledge and then questions we need to answer. And both of these questions came from the Regents, hence why it says January 2020, number 37, and August 2019, number 37. So the background knowledge. Miss Townsend and Miss Manaya went to Luna Park in Coney Island. Miss Townsend paid $170 for 3 children and 2 adults. Miss Manaya paid $360 for 4 children and 6 adults. So right now we know that we're dealing with 2 people, Miss Townsend and Miss Manaya. So what I'm going to do is I'm going to highlight them. So Miss Townsend and Miss Manaya. I know Miss Townsend paid $170 for 3 children and 2 adults. Miss Manaya paid $360 for 4 children and 6 adults. So what we're going to do is, if we look at part A, it says, if X is the price of a child's ticket in dollars and Y is the price of an adult's ticket in dollars, write a systems of equations that models the situation. So what I'm going to do is I'm actually going to go back to the problem or the background and actually annotate it with this information. So I know Miss Townsend paid $170 and she had 3 children and 2 adults. So what we know our equation is going to be is 3x plus 2y. Because we have 3 kids and 2 adults. And we want to figure out how much the price was. Now, Miss Manaya paid $360 for 4 children and 6 adults. So we know that Miss Manaya's is going to look like 360 equals 4x plus 6y. So now what we're going to do is we're going to put that into our question, and we have to make sure it's clearly labeled for part A. So what I like to do is I'm going to write down Miss Townsend. And then Miss Townsend's equation we just said was 3x plus 2y equals 170. Now we're going to put in Miss Manaya's equation. We know Miss Manaya paid 4x plus 6y equals 360. Sorry, not paid. Her equation is 4x plus 6y equals 360. Now, part B says graph your system's equations in the axis on the set of axes below. Here's the issue. If I look at these 2 equations, I can't graph them by looking at them. So what we're going to do is we're going to have to get them into y equals mx plus b form. So the first equation we're going to look at is Miss Townsend's. So we're going to put that in purple. And we know Miss Townsend's equation is 3x plus 2y equals 170. So what we're going to do is we're going to get that equation into y equals mx plus b form. So we know Miss Townsend's equation is 3x plus 2y equals 170. So we want to get it into y equals mx plus b form. So we want to get the y by itself. So to do this, we need to get y by itself. So we want to not touch our 2y. So we're going to get rid of our 3x. We're going to subtract the 3x from both sides of our equation. 3x's cancel. So I get 2y equals negative 3x plus 170. And now what I'm going to do is I'm going to divide everything by 2 because there's a 2 attached to my y. So I get y equals negative 3 over 2x plus 85. And we know that the number attached to our x is our slope. So my slope is negative 3 over 2. And my y-intercept is the number hanging out by itself. So it's an 85. So now what we're going to do is we're going to plot that point 0, 85, which is right here. And we know our rise is negative 3. and our run is 2. So I'm going to go down 3, right 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I'm going to keep on going. Down 3, 1, 2, 3, 1, 2. I'm going to keep on going. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And then I can't go anymore. So now I'm just going to draw a line going through those points. And then I'm done with that part of my question. But the thing is, if you look, I've only graphed one equation. Now I need to graph my equation for Miss Manaya. So we know Miss Manaya's equation is this. 4x plus 6y equals 360. So what we want to do is we want to get into y equals mx plus b form. So we want to get the 6y by itself. So we have to ask ourselves, how do we get rid of that 4x? Well, we're going to subtract 4x from both sides of our equation. So subtract 4x, my 4x's cancel. So I get 6y equals negative 4x plus 360. And I need to get rid of that 6 that's attached to my y, so I'm going to divide each and every single term by 6. So I get y is equal to negative 2/3 x plus 60. Now I get negative 2/3 by just doing 4 divided by 6 in my calculator. Math enter, enter, or if I do it on Desmos, I just convert it to a fraction. And then boom, I get my negative 2/3. So if I look at this, my slope is negative 2/3. So my rise is negative 2 and my run is 3. And then the number hanging out by itself is my y-intercept. So in this case, my y-intercept is 60. So I'm going to plot a point at 60. And then I'm going to go down 2. So down 2, 1, 2, right 3. 1, 2, 3. I'm going to plot a point right here. Now I'm going to go down 2 again. So 1, 2, and right 3. 1, 2, 3. Right here, I'm going to plot a point. I'm going to go down 2 again. So 1, 2, right 3. 1, 2, 3. I'm going to plot a point right here. I'm going to go down 2, right 3 again. 1, 2, 1, 2, 3. Plot a point right here. Going to go down 2, right 3 again. 1, 2, 1, 2, 3. Plot a point right here. And then I'm going to go down 2, right 3 again. So 1, 2, 1, 2, 3. Going to plot a point at the very, very end. And now I'm going to draw a line going through those points. And it goes through rather nicely. And that's the equation, not my equation, that's my graph. So look, part B was just graphing. Now part C says state the coordinates of the point of your intersection. So the point of the intersection is where your two lines intersect. So if you look, my purple line and my red line intersect just once. They intersect right here. So we need to state the coordinates. So if we look, our x coordinate is 30 and our y coordinate is 40. So what I'm going to do is I'm going to say x equals 30, y equals 40. And if we want to write that as an ordered pair, we know it's written as x comma y. So we're going to have a 30 comma 40. And that's your final answer. Now the next part says explain what each coordinate of the point of intersection means in the context of the problem. So we don't want you to say x equals 30, y equals 40. If you look, this is talking about adults and children and all of that stuff. If you look, x is the price of the children's ticket. Y is the price of an adult ticket. So if we're looking at these x and y values, what we're saying is that it's $30 for a children's ticket and it's $40 for an adult ticket. So that's exactly what we're going to be writing. So we're going to say the price of a children's ticket is $30. And the price of an adult's ticket is $40. Perfect. And this all came from the regions. This was a question that was expected of students. Now let's go on to number 2. Miss Kimmick. Miss Kimmick spent $35 to purchase 12 chickens. She bought 2 different types of chickens, Americana chickens and Delaware chickens. The Americana chickens cost $3.75 each and Delaware chickens cost $2.50 each. Part A says write a system of equations that can be used to determine the number of Americana chickens, A, and the number of Delaware chickens, D, she purchased. So if I look at this, we can't use X and Y, we have to use A and D. We have to use A and D because that's what the question is stating. So if we look, we know Miss Kimmick spent $35 and she has 12 chickens. What we're going to do is we're going to actually focus on the 12 chickens first. She has 2 types of chickens, Americana and Delaware. So she can have 1 Americana and 11 Delaware, 2 Americana and 10 Delaware. So we know that we're going to want to add A and D and set them equal to 12. So our first equation in our system would be A plus D equals 12. Now we need to do something with these prices, the $3.75 and the $2.50. Well, we know each Americana costs $3.75, so we know our second equation will be $3.75A plus 2.50D, and we know that she spent a total of $35. These are our 2 equations. And that's it for part A. Part B says determine algebraically how many of each type of chicken Miss Kimmick has purchased. So you can't use guess and check, you can't graph, you have to use the elimination or substitution. Even though this is set up to be looking like elimination, I'm going to use substitution. So I know that A plus D is equal to 12. I'm going to solve for A or D. I'm going to solve for D. So I'm going to subtract A from both sides of my equation. And I get D equals 12 minus A. So I know that everywhere I see a D, I can substitute 12 minus A. So what we're going to do is I'm going to rewrite my second equation. And my second equation was 3.75A plus 2.50D equals 35. So everywhere I see a D, I'm going to put a 12 minus A. So I have 3.75A plus 2.50, and now I'm going to substitute in 12 minus A. And that's equal to 35. Whenever I have a number on the outside of my parentheses, I gotta distribute. So I need to distribute my 2.50 to my 12 and to my negative A. So when I do my distribution, I get 3.75A plus 2.50 times 12 is 30. And then 2.50 times the negative A is a minus 2.50A. This is all equal to 35. Now I'm going to combine my like terms. I can combine my 3.75A and my minus 2.50A. 3.75A minus 2.50A is 1.25A. So I have 1.25A plus 30 equals 35. To solve for A, I need to subtract 30 from both sides of my equation. And I get 1.25A equals 5. And now to get rid of that 1.25, I'm going to divide by both sides of my equation by a 1.25. Which gives me A is equal to 4. So I know that Miss Kimmick has 4 Americana chickens. But here's the issue. I now need to find out how many Delaware chickens she has. Well, if I go back to this equation of A plus D equals 12, or D equals 12 minus A, I can just substitute my 4 in for A. So if I know D equals 12 minus A, I can do D equals 12 minus 4, and 12 minus 4 is 8. So I can say Miss Kimmick has 8 Delaware chickens and 4 Americana. Now let's go on to part C. Each Americana chicken lays 2 eggs per day, and each Delaware chicken lays 1 egg per day. Miss Kimmick only sells eggs by the full dozen for $2.50 each. Just a heads up, dozen is 12. So she only sells eggs by 12s. So she can buy 1 dozen, 2 dozen, 3 dozen, 4 dozen, etc. Determine how much money she expects to take in at the end of the first week with her 12 chickens that she has. So I'm going to organize this. We have 4 Americana and 8 Delaware. Eight Delaware. So we know that each Americana chicken lays 2 eggs per day. 2 eggs per day. So if she has 4 Americana, 2 eggs per day, and she has 4 Americana, 4 times 2 is 8, so she's getting 8 eggs total a day for her 4 Americana. There are 7 days in a week, so we're going to do times 7. So 8 times 7 is 56. So she's getting 56 eggs a week from her Americana. Now we're going to do the exact same thought process with our Delaware chickens. For her Delaware chickens, she gets 1 egg per day. The thing is, she has 8 Delaware, so she's getting actually 8 eggs a day because she has 8 Delaware, so each Delaware produces 1 egg, so she gets 8 eggs a day from them. And there are 7 days, so we just do 7 times 8 again, which is 56 eggs a week. So we know that with her 12 chickens, we know 56 plus 56 is 112. But the thing is, she only sells them by the dozen. So what we're going to do is, now we're going to do 112 divided by 12. That'll tell us how many dozen eggs she'll be able to sell. If we do 112 divided by 12 in our calculator, we get 9.333 repeating, which means that she can't make 10 orders, she can't make 11 orders, she can only make 9 orders or make 9 sales. So she can sell 9 dozen eggs. And we know she's charging $2.50. So what we're going to do is we're going to do 9 times $2.50. 9 times $2.50 gives you $22.50. So she will make $22.50 a week. And that's it for today. So your assignment is to be determined. It could be an ed puzzle or it could be a Delta Math. Miss Townsend and I are still deciding. If you have any questions, please email us or message us on Remind. Have a great day, ladies.